Problem number 2, page 4. You help your mom move a 401.8 Newton bookcase to a different place in the living room. If you push with a force of 65 newtons and the bookcase accelerates at 0.12 meters per second, what is the coefficient of friction between the bookcase and the carpet? What is the force of friction? And these are the two answers. Okay, so we are pushing on a bookcase. All right, so let's draw the free body diagram. Force is going downwards. Force is going upwards. And we are pushing on this object, right? What is that force? And we do have an opposing force of friction. Okay, so is this going to be kinetic friction or static friction? Hopefully you're saying to yourself it's kinetic friction because we already know that the object is in motion. So therefore, it must be kinetic friction. Okay, so this is our free body diagram. Let's pull out our given information. All right, and what is this 401.8 Newton force telling us? That's the weight of the object, right? What is this 65 newtons telling us? If you push with the force of this, hey, you know what? That's our applied force. And we are given our acceleration in which direction? It's going to be in the x direction, right? And it's asking us, what is the coefficient of friction between the bookcase and the carpet? And what is the force of friction? Once again, we do know that we're dealing with a kinetic friction considering the idea that the object is moving. Okay, so we have this right now. Now, let's find out what our mass is. We already have our force due to gravity at the weight of the object. Let's figure out what the mass is. Simply divide 9.8 on both sides of the equation to get our answer. 41 kilograms is our mass. Okay, and let's set up our two force equations. All right, so all the forces going upwards are going to be our positive forces, and all the forces acting to the right or left. All the forces acting to the right are going to be our positive forces, considering the idea that our bookcase will be moving to the right. I don't think it actually explicitly tells us a direction in here, so we pretty much just said we're going to be pushing the object to the right, the bookcase. Okay, so where are all the forces going up and down? Well, all the forces going up is just the normal force. Minus all the forces going down. Is the object moving up or down at all? No. So therefore, the acceleration in the y direction is equal to 0. 0 times any number gives us 0. Okay, where are all the forces moving to the right? The positive direction. Just the applied force, right? Minus all the forces going to the left is equal to our mass times our acceleration. Okay, well, do we have an acceleration here? Yes, it's telling us it's 0.12, so we're just going to drop down this information right now. We only cross out our acceleration in the x direction if the object is at rest or if it's moving at a constant velocity. And we're done with the setup of this problem.